time, position, velocity. The graph below represents the relationship between distance and time on Sarah's walk using motion detector. Part A. Label the section as A for the sections she is walking away from the motion detector. B is label the sections as capital B for the sections she is walking towards the motion detector. And part C is determine average speed for the walk. Now let's look into this distance time graph, right? So here we have time along the horizontal axis. This is the independent variable, and the dependent variable distance is along the vertical axis, all right? Now you can see the graph. It starts at 200, then the distance decreases to 100. It stays at 100 for 5 minutes and then increases. It increases at a slower rate, and then decreases, correct? So that is how the graph is. Now, what we need to do here is we need to label the section as A for the sections she is walking away from the motion detector. So we'll assume that the motion detector is at the origin, right? And from here, if we see, initial distance is 200, and as the time goes by, in the first 5 minutes, we find that this distance has decreased from 200 to 100. So if distance is decreasing, that means the object here, Sarah, is walking towards the motion detector, right? So label the sections A for sections she is walking away. So this is towards, right? Now in this case, the distance remains same. That means Sarah is not walking at all. She is just staying at one position, which is 100 meters away from the motion detector. Now, after 10 minutes, we see that the distance again starts increasing. It increases at slower rate, but it increases, right? From 10 minutes to 30 minutes, the distance keep on increasing. So that means Sarah is walking away from the motion detector. So these are the portions where we should write A, right? So this leg, and this leg. She is walking away from the motion detector. Now in the final leg, from 30 to 40 minutes, the distance starts decreasing, and therefore Sarah is walking towards the motion detector, correct? So part B is sections as B for sections she is walking towards the motion detector. So we have two sections here. First 5 minutes we can label as B, and the last 10 minutes as B. So these are the two sections where we have lines downwards, right? Negative slope. So negative slope also signifies negative velocity, that the distances are positive, and it shows approaching. Positive slopes from 10 minutes to 30 minutes shows that Sarah is walking away from the detector, right? Now part C is determine average speed for the walk. Now, for average speed, what should we do? We need to find total distance divided by total time, right? That gives us average speed. We need to find total distance over time taken, right? For that distance, right? Now here, let's add the distances. Now, as Sarah approaches from 200 to 100, she walks 100 meters towards the motion detector, right? So that is 100, walking towards, and then staying at a position, not walking at all, then moves 100 away, plus 100. Then from here to here, she moves another 100 away, okay, so plus 100. And then from here to here, she walks towards the motion detector, another 50 meters, right? So 50. So that is the total distance covered, correct? And the time taken is from 0 to 40. So we'll divide this by 40, correct? So that is how we are going to find average speed. So we got 100, 200, 300, 350, divided by from 0 to 40, right? And the units are meters per minute, right? So let's use our calculator. So we can calculate like this. So it's going down, so 100, and then from here it goes up 300. So 100 plus, 200, right? 100 to 300. 300 and then coming down 50. So 350, right? So now we can use our calculator. 350 divided by 40 gives us 8.75. So average speed is 8.75 and the units are meters per minute, right? So write meters per minute. So that is the average speed of the walk. So we can write average speed is equals to 8.75 meters per minute. So that is how we are going to answer this question. I hope you understand and appreciate that if we are talking about distances with reference to a motion detector or any source for that matter, then the lines where the distances are decreasing, those are the legs where the person or the object is approaching. And if distance is increasing, then the person or the object is going away from the motion detector. And if we have a horizontal line like shown here, during this time the distance remains same, so the person is not moving, right? So that is how distance and time graph can be analyzed. I hope you understand and appreciate. Thank you.